So this is uh, the live problem solving tutorial session for the NPTEL course optimization from fundamentals. And my name is Pranav. I am a PhD student at IIT Bombay. I'm currently in my fourth year and I work in the area of interpretable machine learning and its application in some protein bioinformatics. So I'll be taking these weekly problem solving sessions in this Google Meet, where in each week we will discuss some problems from that particular week. For example, today we will discuss some problems from the week one content, and you can ask your doubts if you have some questions regarding that particular week's content or any of the previous week contents uh, that you can ask, or regarding anything that we're discussing in that particular session. And what else? Yeah, I think that's it. So we can start today's session, I guess. Is there anything that you want to ask? Okay. So, um, so the course is optimization. So what is this optimization basically? Uh, like, uh, can one of you give me an example of an optimization problem? So this is a I think postgraduate level course. So I am assuming everyone is either postgraduate or maybe final year undergraduate. So you can type in the chat or can just unmute or speak also, whatever is possible for you. Anyone? Like why do we want to optimize something? What are we trying to optimize? How are we trying to do it? And these are things that we learn in this course, but there should be some motivation in us, like why we want to learn this course, right? So basically it is sort of a decision making kind of idea, where you have a certain objective which is mostly like minimizing or maximizing something. That's how you formulate it anyway. So your objective is could be like, I want to maximize my revenue, maximize my profits, minimize the cost, minimize losses, or minimize the time taken to do something, maximize space or something like that. Maximize the number of things you can fit in a certain place. This is some like very vague and very broad sort of general sense of objectives that I'm talking about. In machine learning, you want to maximize the accuracy of your model, minimize the loss that is incurred during the training of your models. If any of you work in machine learning, then you may relate to that. So these are all like optimization problems. So how do you achieve that? You have certain variables which you are tuning. In at least in machine learning, you are tuning your weights. In other problems, you will have some decision variables like the Google map tells you an optimal route from your place to your destination. What is the shortest time that you can reach? So the variables in that are what are all the paths that you can take. Whether you should take a left turn, right turn, whether you should take this road or that route. These are all your variables. So, so the basic sort of components that it has is your objective function. Wait, pen. You have your objective function. Let's call it f of x, and you want to minimize your objective function, let's say, or maximize this objective function. But there will be some constraints like minimize with respect to x, but you will have some constraints on x, like what sort of values of x are allowed, and that is determined by a set of constraints. Let's say gi of x less than equal to 0 or something like that, where I is your some set of constraints. So C is the set of constraints. So these g functions, they restrict what values x can really take. So it can be like like if you uh, consider that Google Map kind of problems, there each road can have a decision variable, which is like whether x road one, x of 1, which is for road 1, whether it should be 1 or 0. So it is a binary variable, so x can only take binary values. X1 can take binary values. X2 is a variable for another road that can take binary values. X3 is a binary variable that can take some value. So if you have, let's say, a to b, b to c, c to d, and you have a to e, e to f, and f to d, and you want to reach d from a. So let's say my variable is x1, x2, x3, x4, x5, x6, and there's a time that it takes to go from each of these routes. So your finally whatever decision that you make, it should be such that you can't have both x4 equal to 1 and x1 equal to 1, right? Only one of these should be 1. So those kind of constraints are captured by this sort of function. I mean, you have to design the function in such a way. That is the modeling problem. And if x4 is 1, then none of these routes can be 1. Like you can't take this route. It's not allowed. If you have chosen this, then you have to go all the way. I mean, here there can be some other option, some g and something else. So those are the kind of constraints I'm talking about. This map kind of idea, Google Maps, finding the shortest path from A to D. So any this is just a broad sense of what is optimization that I'm trying to convey. Any doubts so far? Okay, if there's no doubt, then we can discuss what was taught in the first week. So the first week was an overview of real analysis. Why do we need to have some understanding of that? Because we are dealing with some functions with which are mostly real valued, and these constraints that you impose on your variables, that sort of defines a set of a feasible set of values for x for which you can compute your objective function. You want your minimum or maximum value which is attained within the feasible region which is defined by the set of constraints, right? So we need certain definitions and certain properties that we need to understand so that we have some handle on the problem. We can come up with a way to solve efficiently, develop an algorithm, verify whether the solution that we get is indeed a minimum, is indeed a maximum, and to check if there is no other alternative, or if in some cases it is not really possible easily. So can we get an upper bound, can we get a lower bound? These are sort of questions that you explore in optimization problems, or whether it is solvable at all or not. The feasible region can just be empty, like none of the constraints could be satisfied. So those are things that you want to look at, and for those things we might require some definitions or ideas from real analysis. Okay, any doubts? Okay, so I don't have a background in mathematics as such, but I have done courses and like optimization courses and some related math courses. So if I make any mistake in the definitions, then those who are good at math should try to correct me. Okay, so we had the topics that were covered were mostly like about sequences, their convergence, bounded sequences, and what some open set, closed set, compact set definitions, infimum, supremum, continuity of functions, uh, Weier's theorem, and I think that's mostly it. So, well, so I'll ask someone simple question first. It's related to what was discussed in the class, the video lectures. So I hope you all have seen the video lectures. I won't be repeating most of the things that is there from the video lectures. It is expected that you have seen the lecture prior to attending these live sessions. So one of the questions was like in the discussion on the first lecture itself. I think you have a rope, have a rope, some rope of length m. So in the lecture, I think it was asked what was the shape with max area that you can create by joining the two ends of the rope. What was the answer?
Circle.
Yeah, so it was a circle, right?
It was a circle, sir.
So it was a circle. So I hope you all understood why it was a circle. So if I ask you what is the shape with the maximum, like by joining the two ends of the rope, what is the shape with max perimeter? What will that be?
The perimeter will be same, right? Because the length, right? So length is constant for a
Yes, yes,
rope.
correct, correct. So whatever shape we make, it will be of the same perimeter of length. So that was just I was just taking. Okay. Um, okay. Look at this question. If you have a function f and g from some domain D to R, and f and g are bounded, then if f of x less than equal to g of x for all x in D, then what is the relation between sup f D? What is the relation? Is it equal to, greater than, equal to, less than, equal to, strictly greater than, less than? Any answers?
Less than equal to still should be there for it.
Less than equal to, right?
Hmm?
Less than equal to. That is correct. So what is this? This is sup x in. I'm just rewriting it. F of x, right? Sup x in D g of x. Like the definition of sup is what? It is the greatest, sorry, lowest upper bound. So that means whatever is the sup that is attained, f star, that is greater than mm, f of x for all x in D, right? And g star is greater than equal to g of x for all x in D, right? If this is the f star is the sup x in D f of x, and g star is right? So from this definition, how do you show? How do you show that this inequality holds? You can say f of x is less than equal to g of x is less than equal to g star, right?
Yeah, that's right.
Then how do you get f star here?
Hmm. I think g of x should be less than or equal to f star less than or equal to g star. But
Sorry, can you repeat?
g of x should be less than or equal to f star less than or equal to g star.
G of x should be less than equal to f star.
Mhm.
Why is that?
Uh, uh, I mean, so g of x is always uh, greater than or equal to f of x,
Yes.
right? So g of x is always greater than equal to f of x. So, uh, no, sorry, some mistake. Let me think of it.
This
I
won't
think
be
it's
this
there,
won't
but I'm not able to get it
this
right.
won't be true always, no?
Yeah, it can't be true. Yeah, right.
Yeah, someone else was saying something.
Yeah, I think f star less than or equal to g of x because f star will be lowest upper bound.
F star will be f star is less than equal to g of x.
Because f star would be the lowest upper bound for f of x, and for all f of x less than g of x.
F star is the lowest upper bound for f of x, na?
Yes, but for all x, f of x is less than or equal to g of x.
Yes. So you're saying this is true for all x in D.
Hmm. Yes,
But how can you say it is true for all x in D? Like from here, how can you come to this?
Okay, you're right. The statement is wrong actually, because at some point g of x might be less than f star.
Yeah, it can be.
Yeah. Okay.
You're saying g of x can be less than f star. Mm,
Yeah, g of x can be less than f star because at that point f of x can be lesser than g of x, but f star can be more than g of x.
can you give an example?
Uh, like at one point x, like f of x will
Hmm.
be less than or equal to g of x.
Let's say this is x. F of x is, let's say, here, and what is the relation? G of x is greater, right? Here is
Yeah,
g of x.
then f of x could increase and even go past beyond g of x.
F of x is always less than equal to g of x, right?
Yeah,
Wherever
but at some other x.
you mean to say like this,
Correct, correct.
something like this.
Yeah.
This
So
way.
in this case, f star would be greater than g of x. If we consider,
So this f star, this is our f star. Let's say this is greater than this g of x. That is what you're saying, right?
yeah, yeah, correct.
Yes, correct. Then how do we go to answer this question? So I think if one easy way to answer, I'll tell you. That is when D is compact. Can you answer if D is compact? How you can easily answer this? I think we have learned one theorem. D is compact and F and G are continuous. That also I understand.
Hmm.
D is compact and F and G are continuous.
Hmm. So in that case, the minimum will be always found out, right? If it is a compact, and hence actually its supremum is equal to
Hmm.
maximum,
Yes, yes.
and hence it would be applicable, I guess.
So for each of these, you will have some x star also corresponding. Let's say I have x f star, which attains the maxima,
Mhm.
and x g star, which attains the maximum for g. So we know that. So what can you tell from this? that f of x star f.
is less than equal to g of x f star.
Yes, and because this is the suprema, so this will be greater than gx star g.
Hmm.
So in that way, f star is less than equal to g star.
Yeah.
But what about in this other case when it is not? So one way maybe is like because f and g are bounded, can we use that property?
Bounded but not closed
No,
domain.
no, f and g. I'm talking about f
Oh,
and
yeah.
g.
Okay.
This was when
Domain was
D
right.
is compact.
Yeah.
So f and g are bounded means like f of d basically is a bounded set, right?
Hmm.
So what can we say from that?
So if it is bounded, the lowest point of this bound, right, f of d is always, it should be less than equal to g of d, right? Wherever it reaches, because it is bounded below.
That is this part, right?
Hmm. Hmm. Okay, it still doesn't know that. Yeah.
think from this part we can easily answer. What this is saying is f of x is less than equal to g star for all x and d,
Mm-hmm.
right? And we know f star is the lowest upper bound.
Mm.
So that means f star should be less than any other upper bound, that is g star. Okay.
Mm. Correct.
So we don't really need any other definition. We just need the definition of the supremum.
Yeah.
Boundedness tells us that the supremum is finite. It's not infinite. Okay. Any doubts? This part was clear.
Yeah.
Okay. So let me take a different question. Hmm. Now for the same thing, can you say something about sup f of d and inf f of d? Is this true? For the same question. I should have written g of t, no? G of t, sorry. Because the other one was obviously not true. Is this true or false?
Seems false.
False, right?
Mm.
Because we can, from this example itself, we can see like f star sup is here and infimum could be somewhere here also. So this is false. When can it be true? Can you impose some relation between f of x and g of x or something? Let's say if f of x is less than equal to g of y for all x comma y and d, then is sup f of d less than equal to f g of t.
Yeah, they should be true.
This is true, right? because this is saying like for whatever value of g, f of x is smaller than that. So then your function f of x can never cross any value of g. Like in the previous example we saw, f of x was crossing like this g of, like if this was y, then this f of y value is greater than g of x. But we are saying f of x is always less than equal to g of y for all x, y, and t. That means it will never cross, f will never cross g. Okay. Okay. Uh, let's say your bounded set is yes. Let us be okay. So sup a plus s, is this equal to a plus sup of s? Okay, a is some real number.
Not necessarily true.
Why?
It even can be a negative number type of things, right? So a function of minus some number plus s, which is in the r, right? It can be just decreasing function. I don't know. It can be on a one direction, right? So it should not guarantee, no?
Can you give an example of some set and
Hmm.
see if that holds? Like if it is incorrect for that set.
Oh, okay, sorry. I mean, okay. Let me just think on it. I mean, I thought that there is some function of a plus s, not a plus s as a, I mean, not as identity. I thought it is some function of a plus s.
Ah no, we are not having any function right now
Sorry.
here.
So let me just think on it, right? So
We have a set S which is a subset of R. S is bounded, and we are asking, we have a scalar value A is sup of A plus set S equal to A plus sup of S. So is this equal or is it unequal? Yes, Kandan. False is for this question or previous question?
Yeah, it was for a previous question.
Okay, okay. For this question, is it true or false? Here we are just adding a scalar value.
yeah, I think it should be true.
Should be true, right?
Yeah.
How do you prove it?
I mean, again, it is bounded, so assuming it will reach a maximum. So it's a maximum.
No,
Is
but we are not saying that it is compact, that it is closed.
Hmm.
is equal to sup of s. So x is less than u for all x in s, right?
Right.
A plus x is less than equal to a plus u for all x in s. So what can you say from this? Can I get sup of a plus s somewhere here? So this is basically our a plus u, right?
The right hand side is equals, yeah.
So what is the definition of sup of a plus s? Sup of a plus s is less than equal to a plus x for all
Right.
x in s,
Mm.
and it is also the lowest upper bound.
Mm.
So can I write this? I should write it as. So
Mm.
basically a plus sup of s.
Mm.
So we have this one side inequality. If you have to show equality, then we need the other side inequality also, no? If both the
Yeah.
inequalities are, then that means it is equal. So how do we get the other side?
I don't know, but should we assume soup of a plus s equal to something like a z, and then z will be greater than all a plus s with all x, and then sign will get changed? What done the calculations?
You're saying
Since,
sup of a plus s is equal to some z.
yeah,
Can I write like this?
Therefore, z is greater than equal to a plus a plus x, where x is in a set of S for all x set in S. So, uh, yeah. So, yeah. So, one of them has to be super x. Yeah, that's so that will prove it in both.
Yeah, correct. So here sup of a plus s is greater than equal to a plus sup of s. Yeah, that is correct. Any doubts in this? Okay, let me take another question. Hmm. Same thing, but we have a greater than 0. Then is inf of a is equal to a of inf of s. This true or false? You can follow the same kind of idea that we did over here, right? And take some u equal to inf of s. So u is less than equal to x for all x in s. So because a is greater than 0, au will be less than equal to ax for all x in s. Then what does that mean? Au is less than equal to inf. Yes. So we get one side and we take the other side. V equal to, we say, if A is, so V is less than equal to AX for all xn. So V by A is less than equal to. So from these two we can equate them. So this was same as like just repeating the same things. Only here there was addition, here there was multiplication of scalar, and here A was greater than 0. That was the key. Here we had this extra condition A greater than 0. So if we had A less than 0, then how will the what kind of relationship can you infer?
Should it be still the same?
You are saying if A is less than 0, then also inf of AS is equal to A times inf of S.
Hmm. So yeah, I think the just hypothesis that whatever arguments we made above, right? Wherever we written less than equal to, it will just become greater than equal to. And the other way around. And hence it should be. That is the hypothesis, but
Mm, no.
yeah, if you know. So yeah, u is less than equal to x. So au is greater than equal to ax because a is a negative.
Yeah, you
And
can invert those things, but then you can't introduce infimum there.
okay, yeah, if we do that, then it is not infimum. Yeah.
So then that is the key. Huh? You are going in the right direction.
Hmm.
So then instead of infimum, you should use something else.
Hmm. Supremum. And yeah, it will go the other way around, right? Yes.
So can we write this? This will hold, right?
Yeah.
Because this intuitively, if you see, what we are saying is Like the infimum of AS is like whatever set S was there, we multiply each value with the scalar A, and we take the small A is a negative value, so we take the smallest whatever infimum, the lower bound. And here what we are doing is we take, if we had taken the infimum, let's say the infimum was negative of this set S, and then if we multiplied with the negative scalar, then it would have become positive. But here we took the supremum, we took the largest value, and then we made it sort of negative if it were positive. Yes, just a small example that I'm giving. Okay. So let me take a different question. So you have the sequence 1, 1 by 2, 3, 1 by 4, 5, 1 by 6, like so on. Then is it a converging sequence or a divergent sequence?
Biology.
It is diverging, right? Why?
We cannot get a limit for this sequence. Maybe.
Yes. Is it bounded?
No.
It's not bounded. Yeah, it is not bounded because these odd numbers are going till infinity. But the even subsequence, is it bounded?
In that case, yes.
Is the even subsequence converging?
Yes, it is converging.
It's converging.
Hmm.
So there is a subsequence in this which is converging, and there is a subsequence in this which is not sort of converging. It's diverging. But for a converging sequence, all of its subsequences must also converge, right?
For converging sequence, all subsequence should converge, but for this it need not be, no?
Yeah, because there is a diverging sequence.
Yeah.
Okay. What about this sine of n? Is this converging? And is
No, it's not converging.
Why?
It will oscillate between -1 and 1.
How will we define this sequence? Uh, like we'll have sine 1, sine 2, like that, right?
Mhm.
Yeah, it is diverging. I'm just trying to see if there is a very just crisp way to just justify that. What you're saying is correct. It is oscillating. Uh, so if I would have written it like something like,
But this sequence will be bounded, right?
yes, it will be bounded.
Okay.
If I would have written sine 2 pi n, then is it converging or diverging?
It will converge to 0.
Yes, or got 0 at all values. No? This is converging. What about 2n upon n square plus 1? Is it converging? What is its limit?
It will converge to 0.
Converge to 0. Yeah. Because this we can write as 2 by n. Then what do we do? So maybe I can write as 2 by n upon. So this above sequence is going to 0 and this sequence is converging to 1. And what about sine of n by n?
It's 0 again.
0, right? Because how do you How do you prove that?
I mean, numerator is going to be bounded between -1 and 1.
Yes.
Denominator is a 0, so a finite number divided by infinite.
Yeah, yeah. So it is bounded. In some sense. And this n is going to infinity and it will squeeze. So if I have a function sine of 1 by x, then is it continuous or is it discontinuous?
Discontinuous at x equals to 0.
So how do we make it continuous? Like, does the limit exist at x tends to 0? How do you show that the limit does not exist? You have to show that there is a diverging sequence in some sense, right? Like there is some xn which goes to 0, but sine of xn, it's not converging. There is no limit. Here we had 1 by xn. 1 by xn. Limit doesn't exist. So what you can show is there are subsequences with different limits. Like define xn as just xn like n tends to infinity, this is going to 0, right? And this is equal to sine of n pi. So limit sine of n pi is 0. But if I take a different sequence, 1 by so this will go to 1. We have sort of an odd multiple of pi by 2. And this 4n plus 1 ensures it is plus 1, not minus 1. Right? So you have different limits. So you can say limit doesn't exist in this case. But what about when fx equal to x sine 1 by x?
Yeah, it should be 0, right?
Yeah. How do you show that?
And 0 into some bounded number.
Yeah. So sine is bounded, that means this is x sine 1 by x is bounded between, and this limit goes to 0. This limit also goes to 0. So automatically this will also go to 0.
Yeah.
Any doubts so far? Let's have a set g of n. Okay. So what is this? This is an open set, right? So can we say something about intersection will this be an open set?
Yes.
Why?
That was a property, right? I mean, the proof we can find, but intersection of open sets is always open set. No? Or yes.
Intersection of finitely many open sets is open.
Okay, finitely many. Okay. I mean, but intuitively, right? I mean, zero at itself is never going to get reached, I guess. So it will never be a part of a set, no?
Yes.
So it will never be reaching. So it should be still a open set only.
But what you can see is there will be some set where 1 by 1 by some m.
It will be like, I mean, all are positive numbers or
Yeah, n is integers, natural numbers.
it is natural numbers, right? So it will still be limiting to one only, no?
So 1 will be included or excluded.
One should be still excluded.
Why?
Still, it's still an open set of 1 plus 1 by n, no?
You are saying this will be equal to 0 comma 1.
Yeah, that is hypothesis. Yeah.
But 1 will be part of all the sets, isn't it?
Hmm.
For any gn,
Okay.
1 is less than 1 by n. 1 plus 1 by n, sorry.
Yeah.
So that means 1 is part of all gns, so 1 will be part of the intersection of all gns. So this will be closed, half closed.
Okay, so it will be open at 0 level and close at 1 level. Okay.
Yes. Let's suppose fn is equal to 1 by n comma 1. Okay, so this is a closed set. And this be open or closed or neither. So what do you think this will be equal to?
It should be line between 0. It should be 0, 1, right? It should be actually closing on close on 0 and 1. That's my hypothesis. But
Closed on 0 and 1.
yeah.
So we can see 1 is part of all the sets. That is clear to us.
Yeah.
So it will be part of the union also.
Hmm.
And we need for 0 to, like, from, for given fn we can see 0 is not part of the set, right?
Okay, so it will never be. Yeah. Yeah.
Yeah. So for 0 to be part, it should be part of at least one set. But we don't have any set for which
Hmm.
0 is part of it. So it will be open here.
Yeah.
So 0 is less than 1 by n for all n. So I think that's all the questions that I have. Is there anything, any doubt that you want to ask or anything you want to discuss? So I think the week one assignment quiz question was everyone was able to do it. I think the deadline is tomorrow or something, if I'm not wrong. So you can attempt it. Maybe this session was useful to you if you hadn't attempted it yet. And like, is there anyone from bachelors or all are either working professionals or postgraduate? Yeah, thanks. Thanks, man. Okay, are you able to follow? Okay. Like, what course are you doing? Like, which branch? Uh, are you a math student? Okay. I think first week is straightforward basic real analysis, and second week onward some definitions of optimizations will start. Like some structure will come to what kind of problems will be discussed. So I'll wait for a few more minutes maybe. If you have any doubts, then you can ask. Otherwise, I'll close the session.
Will you be able to share this notebook what you created onto the?
Yes, yes, I'll be sharing that, and I'll upload the video also on YouTube.
Thank you.
I think there will be a link in that NPTEL
Yeah.
where you will be able to access the videos as well as the notes.
Thanks.
Okay. I'll wait for 2 more minutes. You can ask any question if you have. Otherwise, I'll stop the session and close the recording. Yeah, I think the exam will be objective only. So, similar to the assignments that you do. Mostly same type of questions.